Welcome to part 8 of our multiplayer inventory system. This is the second part of the drag-and-drop system. Today we will create the function that transfers items between slots. We start in our blueprint inventory component and open the transfer item function. We disconnect this connection and move the return node aside. First, we want to check whether the slot to be moved was dropped in the same inventory and on the same slot index. We are now working from the perspective of the inventory from which the slot to be moved originates. To check this condition, we first get reference to self and compare it with to inventory component. Next, we create a branch. We also check whether the from index is the same as the to index. We link the whole thing with an AND operator and connect it to the branch. If it is the same inventory and the same slot index, we output an error with a print string and return the return node with successfully false. If the condition is not met, we first make a branch to false. Now we have to check whether the target component is valid, whether the slot to be transferred is valid, and whether the target slot to which the item is to be transferred is valid. We get the toInventory component variable, use the isValid pure function to check whether it is valid, create an AND operator, and add another pin to the AND node. Next, we check whether the from index slot is valid. Search for the getSlotIndex function. Oh yeah. We first have to create this function. So we create a new function and call it getSlotIndex. Then we move it to the setterGetter category. Make this function a pure function and set it to private. It requires an input value named index and of type integer. We create two values as outputs. IsValid of type Boolean and slot of type as inventory slot structure. Create some space between the nodes and insert a branch. Drag the item slots variable into the graph and call the isValidIndex node to check whether the past index is within the valid range. Connect the input index pin to the node and the result of the check to the branch. If the slot index is invalid, there is no slot with this index in the item slots array. We return the value isValid as false via the return node. If the slot index is valid, we read it using getCopy and the past index. Pass it to our return node and set isValid to true. Compile and save. Then go back to your transfer item function. Here you can now use the getSlotIndex function by connecting it to the from index pin. Connect the isValid pin to the end node pin. Next, we check that the toIndex is also valid. In addition, we check whether the true slot index is equal to -1. Connect the whole thing with the OR node and the result in the third pin of the AND note. The reason for this is as follows. If we move an item from one inventory to another without dropping it on a specific slot in the target inventory, we don't know the target index. In this case, we set the index to -1 to indicate that the target slot should be determined automatically. In short, in this case the addItem function is called, which automatically decides which slot the item should be transferred to. We comment on this as follows. The target slot index is valid if not available. Slot index. -1 value is used when you transfer an item to an inventory without specifying a target slot index. Connect the end result pin to our branch. we connect the false execution pin of the branch to the return node above. If the target inventory and the two from and to slot indexes, or just the to slot index, are valid, or the to slot index is set to -1, we perform an additional check on the to index. To do this, create another branch with the condition to index equal -1. If the target index is -1, we first insert a to-do. Target slot index is not specified. We'll take care of this later. Next, we get the toInventory component function. Now, we need a new function, which we'll call addItemToIndex. This has two input values and two output values. The first input is target index of type integer. The second input is item slot to add of type S inventory slot structure. The first output is called successfully and is of type Boolean. The second output is called are all items added and is also of type Boolean. Now we'll create some space, create a branch, and get the getSlotIndex function. Connect this to the target index pin and the isValid pin to the condition of the branch. If the slot is not valid, we add a return node. Then we create another branch to check whether the slot is empty or not. Now we use the isSlotEmpty function to check whether the slot is empty and connect it to the branch. If the slot is empty, we write the item to the slot. Use the getItemSlot to add variable and connect it to the item pin of the setItem function. If the slot is not empty, we need to stack the items. To do this, we create an additional function called stackItemsOnTransfer. We move this function to the category transfer and make it private. Before we continue, we set the visibility of the addItemToIndex function to private. Now open the addItem function as it already implements stacking of two slots. Select the relevant code section, copy it with Ctrl+C, and paste it into the stackItems function with Ctrl+V. Adjust the function as follows. Remove the setting of the target slot. Drag the target slot pin from the iStackable function to the node of the stackItems function to automatically create a target slot input pin. Repeat the process for the slot2stack pin. Expand the two input values in the function and clear the pass by reference checkbox. Rename the input pin slot2stack to fromSlot. Rename the output pin to ArialItemsAdded. Connect the execution pin to the new branch and the two input pins of the function to the corresponding variables. Delete the current item2, add variable as it is no longer needed. Double-click to open the iStackable and HaveSpace function from the Blueprint function library. Add an additional output value, item stack size of type integer. Connect the stack size return value from the interface to the new return node item stack size. This means that we now also return the item stack size with our interface, compile and save. Then we switch back to our Blueprint inventory component. We create a little more space. Right-click on the variable item stack, which is displayed with an error, and create it as a local variable. Click on Create Local Variable Item Stack Size. Now expand the list of variables in the Local Variables section on the left to see the item stack size variable we just created. Do the same for the new quantity from target slot variable. If you compile it once, you will see that this error disappears. Drag the item stack size variable we just created to the graph as of variables. Connect it to the execution pin, because we now want to set it with the return value of the iStackable and have space function. Tidy up the node arrangement a bit for better readability. Now we need to replace the two target slot variables as of way. Right-click and select Get Target Slot. Note that there are two variables with the same name, but they are different. The variable with the F at the top comes directly from the input value of our function, while the variable with the arrow symbol is read globally from the blueprint. But this does not exist. Connect the correct target slot variable with the F to the target slot pin of the setQuantityAddSlot function. Delete the other target slot variables that are not needed. Repeat this for the corresponding connections below. Finally, we need to edit the setMembers node. Use getFromSlot to get the input value of the function and then execute a break on it. We only need the inventory ref pin from the generated pins. Delete the other unneeded nodes. Connect the inventory ref pin of the break to the setQuantityAddSlot function. Connect the pins, move the slot from node down a bit as we need to use it as the target slot. Don't forget to connect the quantity pin. Finally, add a return node and return false. The stack item on transfer function is now complete. And we return to the add item to index function. Drag the stack item on transfer function onto the false pin of the previous branch. Connect the item slot to add pin to the function's fromSlot pin and use the slot read from the target index as the target slot. Add a return node. Connect the area item's added pin to the return node and set successfully to true. At the setItemReturn node, also set both return values to true. This concludes the add item to index function. Back in the transfer item function, drag the add item to index function onto the false pin of the branch. This should then be executed by turnInventory component. Next, we create two branches. We connect the first branch to the successfully returned pin and the second branch to the aerial item's added return pin. In the first branch, if adding to the page wasn't successful, we return false using a return node with successfully set to false. In the second branch, if not all items were added, we return with successfully set to true. Pay close attention to these conditions. Now, we need to create another function called removeItemFromSlotIndex. Set a function to private. Create an input pin named index of type integer. Use the index input pin to search for getSlotIndex. Create a branch and connect the isValid return value of getSlotIndex to the condition of the branch. For steps, for the false pin, create a return node and add an output value named successfully of type Boolean with a value of false. For the true pin, drag the setItem function into the graph and connect it. For the target slot, use the slot returned by getSlotIndex. Pull out the item pin from setItem and create a makeAsInventorySlot node. Hide all pins to create an empty structure and write it to the slot. Add a return node that returns successfully with a value of true. Connect all the nodes and save your changes. With that, the removeItemFromSlotIndex function is complete. Return to the transferItem function, ranges prove. Drag the removeItemFromSlotIndex function onto the true pin of the second branch. Create a return node and connect the successfully pins. Next, Look for a getFrom index node and connect it to the input index of the removeItemFromSlotIndex function. Finally, set the two pins from the addItemToIndex function. Look for getToIndex and connect it to the target index input pin. Next, we search for getFromIndex, grab our getSlotIndex function, and connect the slot pin to the itemSlotAdd input pin. With that, the function is complete. Now let's move to our slot container widget. Here we still need to update the items in the widget when they are changed. This is achieved using the event dispatcher that we previously created in our blueprint component. First, bring the inventoryRef variable into the graph using get, and then search for AssignOnSlotChanged. This is the event dispatcher that we previously created in our blueprint component. Through the assign node, two additional nodes are created: BindEventToSlotChanged, our event dispatcher, and OnSlotChangedEvent, the event that gets triggered when the event dispatcher is called in the blueprint component. Adjust the layout slightly and connect the execution pins. Next, select the four nodes used for update inventory slot data, right-click, and choose Collapse to Function. This will automatically create a new function with these nodes. Name it Update Slot Widget Data and mark it as private. Delete the second input pin that was automatically created by holding the Alt key and clicking on the red mark to remove the connection as well. Open the function, rearrange the nodes for clarity, connect the slot input pin to the break node, save the changes, and return to the event graph. Delete the comment as it's no longer needed. Now drag the newly created function onto the execution pin of the slot change event, connect the slots, and you're ready to test. We press play. Give our character the item's width the T key, open the inventory, move a few items around, and observe how the slots update correctly as the items are moved. The stacking functionality still works as expected. However, swapping items is not yet implemented. This will be addressed in the next part, as it's a simple function. I'd love to know if you can figure out how to implement the swap function yourself. Let me know in the comments. As always, if you like this video tutorial, leave a like or subscribe to the channel so you don't miss the next episodes. Thanks for watching.